this lecture, we're going to go over plotting in MATLAB. So we're going to learn how to create proper plots using the MATLAB plotting function. So we have plot, subplot, log, semilog. No, this should be a lowercase p. Should this f. So we're going to learn how to format proper plots using the correct commands. We have figure, grid, axis, legend, title, x label, y label, limits. And we're going to format plot elements using property name, property value. So we're going to learn how to use edge color, text color, font size, marker size, and all to edit some looks of our graphs. So proper plots in MATLAB, the simplest way to create a plot in MATLAB is with the plot command. Plots are created in figure windows. If no figure window exists, one is created. If one or more figures exist in MATLAB, it will erase the previous plot to create a new one. This is an important point. There is going to be a command to have that not happen that we will learn later. The figure function creates a new figure. So the plot command is simply plot a, b, c, where a is the horizontal axis or your x values, b is your vertical axis or your y values, and c is the optional test string that you can use to specify line or symbols or types. You can be repeated for multiple data series. For example, we can plot A1, B1, C1, A2, B2, C2. So it looks for lumps of two variables together separated by commas for plotting. So what are some special symbols and types in MATLAB to use in our plot? So if we want a solid line, you put in a single dash. If we want a dashed line, you put in two dashes. If you want dash dot, you put in a dash and then a dot. If you want dotted, you use a semicolon. If we want to change some of the colors, K is black, B is blue, C is cayenne, G is green, M is magenta, R is red, Y is yellow, and W is white. We can have different marker styles. We can do an asterisk, we can do a circle, which is an O, we can do a cross, we can do a plus sign, we can do diamonds, we can do a square, we can do a point, we can do a triangle pointing downward, a triangle pointing to the left, a triangle pointing to the right, a triangle pointing upward, a hexagram, and a 5-pointed pentagram. So there's different formats. We can also change the line width of our graph. So the function to do that is called line width. You give it a numerical value in single quotes. So the default is 0.5, which is very skinny. Marker edge colors will change the border of your markers. Marker face color will change the face color. Marker size will change the size of the marker. We can also have a legend. And inside of our legend, we can change the line width of the legend, the edge color of the legend, the color of the legend, the text color, the font size, text angle, and font weight of our legend. And we can also change the location. So in our figure window, it works on a coordinate system, so we can have north, south, east, west. You can also have it defaults to inside of the box. If we want to move it outside, you have to do an underscore outside. Best will put it in the best location, and best outside will put it in the best outside. So there's ways you can manipulate your figures. Much like in Excel, you can also open the figure window itself and do edits in the property manager, which is typically what I do instead of doing it with lines of code. Some more properties for text colors. We can change our background color, just the background color of the text. The default is transparent. We can change the color of the text, which the default is black. We can change the edge color, which is none. We can change the line style by making things thicker or not. We can change the line width. We can change the margin. The font angle, we can have normal, italics. The default is normal. Font size, we can change the size, and the default is 10-point. Font weight, you can have normal, bold, or demi, which is, I guess, like a half bold. The default is normal. You can have horizontal alignment and vertical alignment. Yeah, just different commands. So let's look at a graph of a proper plot here where we're plotting power versus height. We have two data series here. So we have one for mass is 100 kilograms and the other for a mass of 250 kilograms. Notice we have our grid lines on, we have axes labels. So let's dissect the code that we use to create this. We use some bookkeeping in the beginning. The first thing I have are my H values for my series 1, then my H values for my second series. I have my power values for my first series, my power values for my second series. So then I did my plot command. So first I plotted H2 and P2, and I said I want them in plus signs. And then I said H1, P1, and I want them in circles. I set an axes. The axes function allows you to set the limits of your axes. The first two are your X, the second two are your Y. You give them as a vector. I set a title for the graph. I said it's experimental data, multiple data series plot. I set a legend. The command for legend is a legend. I defined my two data series in my legend in the order that they are graphed. I put an X label, I put a Y label, and I turned grid on. Notice here in my plot command, I actually am missing the colors. That's because these are using the default color orders of MATLAB. MATLAB does change the color of each data series that you plot automatically. So if you have nonlinear theoretical data, much in the same way that Excel connects data points with straight lines, so does MATLAB. So if we were to plot a graph of v is equal to exp of minus 2t times cosine of 3t, you would expect to get a dampened cosine curve. The problem is I use a spacing of 0.5 between 0 and 10. So I'm getting 0, 0.51, 1.5, 2, 2.5, 3, and so on. So it's creating this very jagged sawtooth type graph. Also note that the default line for a MATLAB plot is a solid blue line. MATLAB defaults to solid lines and then does cycle through the colors. What can I do to smooth out my graph? Well, I can increase my time step. Instead of 0.5, if I go by 0.5, I will put my data points much closer together so that even though they're all connected with straight lines, if you were to zoom in very closely, you would have the appearance of a smooth curve. So what if I want to put multiple plots on one picture in MATLAB? I can do that using the subplot command. The command is subplot, and then you put in the number of rows, number of columns, and the position of your subplot. The position in your subplot is where the plot commands will put your plot. The numbering starts with the top left corner and goes across each row. So this would be location 1, 2, 3, 4, 5, 6, 7, 8. So let's review how to plot certain things. So we have our linear type function, which to plot that in MATLAB, your graphing code is simply plot x, comma, y. And you'd have a nice rectilinear graph. If we wanted to plot a power graph and we wanted to plot it on a log-log graph where it appears linear, we can use our log-log plot function in MATLAB, which will create a log-log graph, and then you put in your x and your y values. If we want to do an exponential, we can create a semilog plot in MATLAB by using the semilog y command. There is a semilog x command if that was what you wanted, but again, logarithmic scales on the x-axis are not covered in this course. Here we have a proper plot of our logarithmic data. It follows the same rules as it did in Excel. So here we have our first example. We're going to graph the data gathered in the following row matrix. Row 1 is the time and in minutes, and row 2 is the concentration of the hormone. So we want to make the background white. We want the data to be blue. Solid triangles that point to the right, we want them to be size 10. We have axes labels and titles are in size 12 font. We want grid lines, spacing, axis limits, and axis labels must match. So how are we going to do that? Well, first of all, we're going to close any figures that we might have. That's what the close all function does. We have our data listed. Here's row 1, here's row 2. We're going to create a figure. Inside the figure command, if you say color, it will set the background color, and then we have to specify what color. So I'm saying set the background color to white. Here's my plot command. I want to plot row 1 is our time, is my x-axis. Row 2, all columns, is my data. I want blue right-facing triangles. I want to set the marker size to 12 and the marker color to also being blue. This will only set the outline color. I need to do the marker face color to be blue as well to make them filled in. MATLAB defaults to not solid filled variables. I'm going to use the title function to put a title on my graph. It's going to be relative hormone levels following exercise. I'm going to use the font size command to make 12 size font. I'm going to use the X label command to say that my X label is time in minutes. I'm going to set the font size again to 12. I'm going to do the same with my Y label. I'm going to set my Y label and my font size to 12. I want to do grid. I'm going to turn my grid on. You can do grid on. It can be done both ways. I want to set my axes limits. I want to go from 0 to 40 and 0 to 100. And then I'm going to set these last two commands to be the size of my Y ticks. So GCA is just how you turn on formatting. Y tick is the labels of the tick marks. So I want to go from 0 to 100 in steps of a 10. And I want them to be font size 10. So I'm setting my tick values. My second example here is we have mass of a hollow sphere depends upon the outside radius. We have density. We want to create a model outside the radius from 12 centimeters to 18 centimeters in increments of 0.5. We're going to set the inside radius to 8 centimeters and the density to 3, and we're going to make a graph. Again, we want a white background as a green line with a width 4. We want grid line spacing, axis limits, and axis labels to match. So this is the graph that this code is going to generate. We're going to put in our variables. We have our density, our radius, our inner radius, our outer radius, our equation for our mass. We're going to close all open figures that we have. We're going to set the background of our figure to be white. We're going to plot our R as a function of mass. We're going to make our line width 4, and we're going to make our color 0.50. I'm using an RGB designation for the color to get a dark green line that isn't one of the built-in colors from MATLAB. I put my title in, I put my axes in, I put my axes labels in, and I wanted to set my font size to be 12. So in this example, we're trying to create a figure that has 3 subplots on it. So first you have all of your data. We're going to close all any open figures. We're going to create a figure with a background color that is white. We're going to create a subplot with 3 rows, 3 columns, and this first one is in position 6, so it's 1, 2, 3, 4, 5, 6. We're going to use our plot commands. We're going to plot R, H1, we want them to be blue asterisks. We're going to make the marker size 10. We're going to turn on our grid. We're going to put our axes labels on, and then we're going to create another subplot, this time in position 2, so we're now making this one. So we have R, H2, we want left-facing black triangles. We're going to make the marker size 10. We're also going to make the marker face color black so we can fill in these markers. We're going to turn on the grid, and we're going to give this plot its axes labels. We're going to turn on another subplot, this time in position 7. We're going to plot the remaining data in red crosses. We're going to make our marker size 10. We're also going to make our line width 2 because the symbols that use lines can sometimes be thin. And we're going to put our grid on and put our axes labels on for that plot. And this time we're going to create this plot that has 2 lines on it, and it's also on a log-log plot. So let's see how we do that. We have our radius data. So we're going to make our figure. We're going to make it white. We're going to create our volumes. The order here doesn't really matter. We're going to create a log-log plot. So we're going to use our log-log command instead of our plot command. The plot makes rectilinear graphs. We're going to put on our x variable, which is R, and our v variable, and we're going to put it in blue, and we're going to make it a line width 4. Then I'm going to use my hold on command. The hold on command allows you to put multiple lines on the same graph. This time I'm going to use the plot command, and I want to put on RV2, and I want to put it as red dot dashes with a line width of 4, because I'm plotting this data 2 different ways. And then since I'm already on a log-log plot, I can just use the plot command. I'm going to put in a title. I'm going to say T is equal to challenge graph 2. I'm going to say my title, T, color, size, color, size of the number for the color, font size. Put my grid on, put my X label on, my Y label on. I'm going to take my legend. So I want to say L is my legend. It's going to have R is equal to 15 centimeters. R2 is equal to 30 centimeters. I want to set L location best edge color 10. So edge color 0, 0.50. So what I'm doing with this set is I'm saying take my variable L, which is my legend, put it in the best location, make the edge color green, and make the thickness of that line 2. So that does this for how to plot in MATLAB. And now in the next lecture, we're going to look at how to create trend lines.